Bismillahirrahmanirrahim. Assalamu alaikum. We are discussing direct proportions, and we define direct proportions as if we have two quantities, either they increase or decrease together, or we can say that the quantities are said to be in the direct proportions if their increase or decrease is having the same ratio. That is, they are increasing or decreasing with the same ratio. So for that matter, what we did was we said if y1 is the one quantity and x1 is another quantity, so y1 over x1 is one ratio. And if we want to find some unknown, so we said y1 over x1 is equal to y2 over x2, and we were able to find the unknown thing. So let's continue with this direct proportion and discuss another method. So let's take an example to understand how the things are moving. Suppose, example, cost of transporting goods is directly proportional to distance traveled. Okay, so the cost of transporting goods is directly proportional to distance traveled. So we can say, if say this is C and this is D, so what we are saying is C is directly proportional to D, right? And we know that these two, if we have two quantities, their ratio is always equal to a constant, because they are increasing or decreasing with the same ratio. For that, what we did was we said C is equal to KD, and this K is the constant, and if we are comparing the ratios, the constant is always going to be the same for any two quantities. Okay, so suppose we have the cost is $100 for 50 kilometers traveled. Okay, and we have to find connecting equation. So let's apply the values. We have 100 is equal to K into 50. So K is equal to 100 over 50, so is equal to 2. So we have 2D. This is our connecting equation. Why it is connecting equation? It is connecting cost with distance traveled, and we have a constant value over here. That is, whatever the distance is traveled, it is doubled to give you the cost, right? So cost is equal to the double the distance. So this is the value of the K, and this equation is connecting equation. So if we have any of the two things, like if we have cost, we can find distance. If we have distance, we can find the cost using this connecting equation. So this is another approach of finding the unknown in case of the direct proportionality. Suppose now we have, if the distance traveled is is 35 km. So what is cost? So we can say C is equal to 2 into 35. So cost is $70. So this is another approach. And this thing is our connecting equation. And in this connecting equation, we have the value of the constant, because when we were saying that we have two quantities, they either increase or decrease with the same ratio, and this same ratio is here 2, and it's going to be 2 no matter what are the cost and the distance traveled. So this is going to remain the same. Okay, so let's take another example, and we'll make a graph for that example also. So in the next example, we are going to take pressure and temperature, and the pressure is direct proportional to the temperature. If the temperature is increasing, pressure is increasing, temperature decreasing, pressure decreasing. So we can write it like this: P is proportional to T, and of course, to remove this sign of proportionality, we have P is equal to KT. Okay, now we have this equation, and to find the connecting equation, we need some initial values. Supposingly, if we say that we have pressure P equals 25 pascals and T equals 10 kelvins. So if we apply these values, 25 is equal to K into 10. So K is equal to 2.5. So P is equal to 2.5 T. So this is our connecting equation. Okay. Now this connecting equation is connecting pressure with temperature, and it is showing that the ratio between the pressure and temperature is going to be equal to a constant, which is 2.5. So because we say that the ratio of increasing or decreasing is always same, and in this case this constant is 2.5. Okay, now to make a graph, let's take some values. And we have discussed it that the graph of direct proportionality is a straight line, and it also passes through the origin. Okay, now we have temperature and pressure. Okay, so for the temperature, if we take 5, 10, 15, 25, okay, and we have here, and we are going to apply in this, and we have 12.5 pascals, 25 pascals, 37.5 pascals, and 50 pascals. Let's take it 20. So this is our values, and we have calculated using this connecting equation, applying the value of T here, and we get pressure. Okay, we'll apply these values in a graph, and we are going to get a straight line which is also passing through the origin. For the origin, when I say origin, if I take temperature 0, T is 0, the pressure is also going to be 0. So that means that they are going to pass through the origin. So let's draw a graph. Okay, I'm going to draw a graph of pressure and temperature, and going to apply the values which we have already decided. Let's say I'm going to take the temperature over here like this, 5, 10, 15, 20, 25. Okay, and I'm going to take pressure over here, and for that I'm going to start from 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Okay, so the first value was 5 and 12.5. So this lies over here. Okay, then 10 and 25. This is here. Then it was 15 and 37.5. Which is here. And then 20 and 50, which is here. And if we say the origin, this is origin 0 and this is origin. Okay, so let's see. Okay, this is a straight line because of direct proportionality. Pressure is directly proportional to temperature, so it is a straight line. It's also passing through the origin. So, and we have proved that the graph of the two quantities which are in direct proportion will give us the straight graph. Okay, thank you very much.